Okay, hello everybody. Tuesday, April 21st. So have some weeks to go. Hopefully, uh, you're managing the grind of it a little bit. I know that this learning to program can be a grind sometimes. I wish there were a way around that. If there were a magic pill, though, then well, a lot of people would take it and then hope to have exciting, rewarding careers in it. So unfortunately, it's a process to get there, and but that is one of the reasons why it's valued so highly is because not everyone wants to go through the process. So um, hopefully you're bearing with it and you're finding things. You're enjoying the reward of solving problems because some of these are hard. Okay, so the plan for this week is what I'm going to do is I'm going to break the lab up into parts. So I think I will do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 functions in the lab. So I'll probably do 1, 2, 3, 4, 5. Yes, I'll do 5 of them. And then I'm going to do some Project 3 stuff. So let me put a big uh, set of notes up there to tell everybody that's what is happening this week in CSCI 20. Um, Lab 12, Part 1, Tuesday. Project 3 ideas, Tuesday. And then Lab 12, Part 2 on Thursday. And then Project 3 ideas continued on Thursday. So kind of the same twice. Half the day will be spent on lab and the other half will be on looking at ways we can apply what we've been learning on lab to the project. So that's the plan. Today's the 21st. So we'll start with the lab. Once you've seen one of these solved, they're pretty repetitive. Uh, the thing I want you to note though on this lab is that these are all functions that are receiving slices and other data as parameters. Um, Realizing that you can pass slices as arguments to a function is super helpful on the project. Um, this project is the first one where I think you'll value the power of functions a lot more than you've been able to on other labs. Because or on other projects, this project, if you don't use functions, can be a lot more painful than if you do use functions. So we'll look at ways to take advantage of this idea that you can pass things like slices to functions. You can also return slices from functions that may or may not be of use on the project, but you can pass slices, one or more, to a function. You can return slices, one or more, to a function, or from a function. Okay, so let's just get going here. These are slices, so what we know about slices, we've been given no direction about how to solve these problems, but what we know about slices is that counting loops or range loops are very powerful ways to process slices. And I'm just sort of tipping you off that almost all these problems are here to give you a chance to continue practicing using loops to process a slice. So what I'm supposed to do in this first function is return a slice that contains all the strings in the given list, this list, matching a given length. So for example, if I had this as a slice, if that were my list, and let's say 4. So if I were given this list and said, give me a new list containing all of the strings of the old list that are of length 4, what I should get back is, let's say 3. That one was more interesting. So all the length 3's from here would give me back yes and yep. So that's what this function is supposed to do. Take a list. I'm not going to actually know what it looks like, but take a list given a length. So list given a length, return a new slice containing all the strings from the first list that match the given length. Okay, so how do we do that? The first thing we need to do is to give ourselves a place to hold our results. So I'm going to declare a string. That's going to be the thing that I send back. So at the end, I'm going to return a set of results that's a slice of string. Initially, it's empty, and that's entirely possible, so that's good that my algorithm will handle that. If they give me a length and there's no matches in this list for that length, then I will get empty results. So this works perfectly. Okay, so I'm set up to make some results, and once I'm done processing, I'll return those results. So in the meantime, what I need to do is look through this list. Now I happen to like range loops a lot, so I'm going to start with a range loop. We take a pairing. This is an index and a string that we get as we range over that list. Remember, I don't know what's in it. I just have to write an algorithm that's smart enough to figure it out no matter what it is. So as I range over this list, I'm going to get index string pairs, and what I'm interested in is any of these strings whose length matches this length. I want to keep that as part of my result. So if the length of s, that's the number of characters in this string that I got out of this list, if that matches the length I'm looking for, so if the length of this string pulled from this list matches the length that I'm targeting, well, then I want to add or append that string s to my results. So every s string that I get from this list that has the required length gets added to my results. That's it. I notice that inside of my loop I am not using this I, so I will ignore it. And then I'm going to go run the test. I'm going to fail a whole bunch, but maybe I will pass strings of length, so let's try it out. So I have all the files here. I downloaded the fruits.txt file because the test uses it. I don't have to worry about it, but the test uses it. Here's the lab12.go. Here's lab12 that I worked on earlier to make sure that I had it all right. So you won't have that part, and then here's the test. So I'm just going to type go test. It's going to apply this test to my lab12 go code. I'm going to fail a whole bunch. Did I pass any? To know that, I'm going to have to run go test with a -v. And I did pass one. So here's, I actually passed 2, but one of them was the test that had already done that part for me. It's reading a file. Here's strings of length, so that one passed, so that's good. Okay, if you want to, by the way, we can. Let's go look at the test really quickly just to see what's going on inside of there. So the test, we never touch that code. It's already written to be complete. But if I look at the test, I will notice that one of the things that the test does is it loads a file. So that's how fruits.txt gets in here. And if you look at, so for example, test strings of length, it actually loads the fruits.txt file automatically for me. I don't have to worry about that. And it gets a list of fruits, and then it uses my function that I just wrote to look for fruits of length 10, and it's expecting a specific amount because I created the fruits.txt file. Anyway, so that's how that's working. That's where fruits comes in as part of the test, and the test already has its own code to load that file for you, so you don't have to worry about any of that. Okay, so back to this. We pass strings of length. Um, strings longer than. So in this case, we're not looking for strings of a specific length, like 3-character strings. I want, if they give me a length that says 3, then I want to find all the strings in this list that have a longer length, whose length is greater than that. So that's pretty similar. I set up a slice to hold my results. Ultimately, I'm going to do some processing and then return the results that I produce. Going to range over the list, pulling indexed string pairs. I'm going to look at the length of the string I pulled from the list. If that is greater than the target length, so this target length right here, I don't know what it is, but eventually someone's going to use this function and they're going to specify that. The test does. If the length of that s is greater than the target length, then that's one of the ones I want. So I will append that to my results. Oh yeah, so if I look in the loop, I'll notice I did not use the I, so I'll ignore that. Do a test with -v. I should be passing, I hope I'm passing strings longer than, which I am, plus strings of length. So passing those two, failing the rest. That's function number 2. I went fast because it's the same thing. Strings shorter than, well, that's pretty easy. I look through a list. If my length is less than that, then that's one of my results. So set up to hold some results. Ultimately going to return those results. I'll use a counting loop this time, just to remind you about those. Neither one is better than the other, they're just different. Counting loop is always I equals 0, I less than something. In this case, it's the length of the list, because I want to read the entire contents of that list. So now I need to get one string from the list, and to do that I'm going to index it, and the index will be the I. That's what the counting loop actually does. So this part gives me one string from the list, just in a different way than the range loop does. I get the length of that string, and so if the length of that string is less than the target length, then this string shorter than function, I want to add that to my results. And now I'm not ranging, so I just have to use indexing to go into the list and get one string at an index. So the counting loop will index from the start at 0 all the way to the end of the list. I'll look at the length of each string compared against the target length, and the ones that are shorter than the target length, string shorter than, I will append to my results. So I'm going to run with, I'll just show you again what I'm doing. I'm running it verbose so that I can see the passes and the fails. If you don't run it with verbose, you only see the fails. But I want to see the passes with verbose because I want to know a string shorter than passed, and it did. Also strings longer than, passed still, strings of length, passed still. So if you note, those three functions are pretty much the same, just the way they use the length is different. Okay, that's 3 of them. Let's do a 4th. So strings beginning with returns a slice containing all strings in a given list that begin with a given prefix. Okay, so this is not links anymore. This is look for a specific prefix. And what I mean by that is right, so if I'm given the prefix the, then theater would have that as a prefix. right? And the is not a prefix of apple the. Um, in that case, the is a suffix. So that's what this one's supposed to do. Look through a list, find all the strings that have a start with a particular prefix, right? So if I had, if I started with this, and a prefix that I'm looking of is then the list, the results I get back should contain theater and them, right? Those are the two, those as the results are the two strings in the original list that started or had a prefix of the. That's what this one's supposed to do. Now, Go should be able to help us with this. Let me first set up to produce some results. This one also returns a string slice, so the results will be a slice of strings. So all the ones with the positive test on them return results. Okay. So the other thing I'm going to do though is I'm going to go to the Go documentation for strings and look for this word prefix to show you where we find this stuff. So let me bring up my browser real quick. I'll come back to the code in a sec. So Golang strings is what I'm going to search. Strings. And I'm looking for the word prefix. There's a function right here. Has prefix. That's exactly what I want. I want to know if one string has another string as its prefix. So does some string s have as its prefix some other string called prefix? I notice it's going to return true or false. So this will return true if prefix is a prefix of s, and it will return false if prefix is not a prefix of s. So strings.hasPrefix is the whole trick here. I'll use a counting loop again and then I'll switch back. I happen to like the range loop better, but neither one's actually better. It's just whatever you like. So I'm going to count through the whole list. So counting loop. If strings.hasPrefix. So the string that I'm looking at is list at I. That's one of the strings in the list. The prefix I'm looking for has been supplied as a parameter, that prefix. If that returns true, then I want to add that to my results. So I will append that string. So as I loop through the list, every string in that list that has that prefix, I'm going to add it to my results. That's what I'm doing here. So now back, let's run the test. I'm running it with -v, remember, because if I don't use the -v, I will only see the failed test and not the passing one. So -v, I can look through here and see if strings beginning with, I passed that test. So that's good. That's 4 of them. You see the pattern though? Results, process the list to add to your results, and then return your results. Okay, last one. Contains, returns true if a given slice contains a target string. So contains means that this target string can be anywhere in there, not just as a prefix or a suffix, but as long as that pattern of characters is anywhere in the string, then I want to keep that as a good result. So if we go back, let me bring the browser up again for a sec. If we go back, and I go back to the top of this document, there's actually a contains here, which is one of the reasons why I use that terminology is so that, to help you find this. So contains So I look in S to see if it contains a given substring. That's what sub-str substring. So if you've had set theory, substring is just that combination anywhere in there. Okay, so that's going to be the key to this one is strings dot contains. So this one's different though because I'm not doing results as a slice anymore. I'm doing results as a bool. So wait, hold on. The given slice contains a target string. Oh, this is totally different. Never mind that. That doesn't seem to be what it's asking for. I think it's just saying, does this string live in this list anywhere? Can I find this string in this list? Okay, that's different. Notice though my result, now it's not results because I'm not making a list of results. I'm just doing one result. Can I, anywhere in there, find this target in this list? So don't mess with that contains. That's not going to help here, I don't think. It's probably okay, but we don't need it, I don't believe. Loop through. I'm switching back to the range loop because I just find that more pleasant to work with personally. Anyway, so I'm going to range over the list that I've been given. I'm going to grab string index pairs and I'm going to say, is it case sensitive? Case insensitive. Ooh. Okay. Let's go rethink this a little bit. So what that means is if I'm given a list, that should be false. So if I'm given this as a list and I'm looking for this string in it, then that should return false because orange is not in that list. But if I'm given this list and given apple, well, then yes, apple is in that list. But what happens if I'm given apple? So what it's telling me in case insensitive is that since it's not sensitive to the case, that means any way that apple is spelled should come back as true. I accidentally erased one at some point. How did I erase one? Okay. So this apple should return true. So I'm going to have to do work to make sure that that happens that way. Okay. So this still is a strings thing. It's just not the one that I was thinking. So what do we want to do? This is the way I would do it. You have a toUpper function and a toLower function. Either one of these will work. But the idea is to just make all of the strings be either all uppercase or all lowercase, and that way any comparison between them is going to match even if the original spelling wasn't the same. So the way I'm going to do that now is I'm going to if strings dot, for some reason I always pick toUpper. Doesn't really matter, but that's what I do. So as I grab S's out of this list, I'm going to uppercase them, and then I'm going to compare those against the uppercased original target up here. So that is how I get case insensitivity. If those are matches, then the result is true. So if that even happens once, then yes, the result is true. Now there is another way to do this, but wait, you can't see anything. Anyway, so what I added is if the uppercase version of this S I get from the list matches the uppercase version of this target, that way there's no spelling issues, it's just all uppercase everybody. But you could say toLower and toLower and it would be the same. Then the overall result would be true, that I can actually find a match, in case insensitive match, for this target in a string in this list. And then when I'm done, I'll return a result which will either remain false because this never happened, or it will be true because that did happen. Oh, did it again. Nowhere in the loop am I using the I, so I'm going to ignore that. Gonna test with dash V so I can see the passes. And I'm just gonna see, so there's contained string I passed. Strings beginning with I passed. That's 2 of them. Strings shorter than I passed. That's 3 of them. Strings longer than I passed. That's 4 of them. And strings of length I passed. That's 5 of them, which is all I plan to do today. Is pass those first 5, and then I'll work on the others next time so we can go on and talk about the project a little bit. But hopefully you're starting to recognize these patterns, the way that we use loops to make life easier when we are processing a slice. And it would be the same if this were an array. Remember, the difference between a slice and an array for our purposes right now is that you can append to a slice. But it also turns out that you can edit a slice, which if I have a chance I'll show you how that works. Where are we at? 427. 427. 1427. 227. Okay, so I'm going to switch gears and do some Project 3 stuff. Our goal is to, my goal is to help you envision how you might organize your Project 3 and encourage you to use functions to make your life easier on Project 3. So let me, not that. Let me make a new file. Okay, sorry about that. Oh, to run a test. Um, so to run a test, you type go test. I'm in the wrong. You type go test. By default, go test will either show you a pass when you pass all of them, or if you don't pass all of them, it will just list the ones that you failed. So to see everything, you do -V, which means verbose, which will tell you your failing ones, but also it'll tell you your passing ones, so that if you're in the middle of working on them, you can at least see, okay, what did I pass? That's -V. Okay, I'm going to turn the browser on one more time, and I'm going to go grab the Project 3 starter file. So Project 3 has a lot of scary looking stuff, but if you go look at these screen captures I did, our goal today is going to be to try to print just this grid part, and maybe not the entire grid part, but at least some of the grid part. So this 1, 2, 3, 4, 5, these are printing out slices. There's 5 slices in there. And then there's a separator because the part at the end is special part. That's a calculated cell. The stuff to the left of the vertical bar, that's the data cells if you've ever used a spreadsheet. These are just ones where data is typed in basically, and then at the end is some calculation like sum the cells or average the cells, that kind of thing. So our goal today is to see if we can make a function that will let us print some part of this grid. And then I'm going to use that as a reference, so I'm going to open that up in a tab, and then I'll come back here as I'm working and see and compare notes. It also gives me some starter code. One nice thing about the starter code is it has a clear screen function in it, so I can use that. So I'm going to grab that and put that. So I pasted it in to this file over here. I know. Calm down, compiler. Okay, so we wanted to see if we can print something like that. So I'm going to start by making a slice. And we know that we need size 5 slices. You can make an array if you want. What do we want? Arrays, slices, arrays, slices. Since we're on slices, I'm going to go with slices. So I'm going to say row 1 equals make a slice of float 64. That is what the project tells me to do. Of size 5, also what the project tells me to do. Okay, so what I want to be able to do is print that out pretty like the picture had in the screen capture. So what I'm going to do, and I'm actually going to use these notes as a guide, so display all rows. So I'm going to fill in right here. What I want to do is write a function where I can just say I want it to display a row, and that be row 1. If I can get in the habit of creating functions like this, I can find places to save myself a lot of duplicative work. Okay, so let's start with that. We're going to write a function called display row that takes a slice of float 64 and prints it. And here's a note up here. It says your function. So okay, I will put my functions with this. No. Do not create a separate function for each row. You'll see me do this in a second, but you'd be kind of wasting the functions. Then you're not saving yourself any work. So think to yourself, am I doing more work or less work? So if you're doing less work, then you're sort of on the right track. If you find yourself doing more work, then there might be a better way to do it. So let's see how this plays out. So let's make a function. We'll call it display row. It is supposed to accept a row of float 64 and print it. So one thing to note here about my function is that I didn't say row 1, and I did that on purpose. I don't want a display row function that can only print one row. I want a display function that I can pass in all my rows to if I need to and have each of them be printed for me. So when you're writing functions, try not to think about specifically what you have in other parts of your program. Try to write this thing as if you were trying to help a friend out. So your friend says, oh man, I got to print 5 rows, and you think, well, I can write a function that'll print 1 row, and that should solve your problem, if you think about it, right? Because if I can make a function that prints 1 row, but I have 5 of them, like I'll make a row 2. Well, that function should work for any row. Why wouldn't it work for row 2? If the thing is a slice of float 64, which row 2 is, as is row 1, then that function should work the same no matter which row it is. So this is now beginning to save us some work, because when I write my function, I'll just think, okay, I can see from the screen capture, I can see here in the screen capture that every row looks the same, which means that I only have to figure out one way to print them and just apply that same printing method to every row, and then they'll all look the same. So that's my goal here. One function to print them all, as it were. Okay, so what does it mean to print a row? Mostly it means looping through the row. I will call it a, what should I call it, a value? I'll call it data. I get an index and some data as I range over that row. Which row? It doesn't matter. Any row. In fact, any slice of float 64, this will work for. Any slice of row 64. So if you give me a slice of float 64, I can print it for you. All right, so what do I want to do? Basically, I want to do a format.printf of it. I'll do a %.2f. I'm using 0.2. Oops, you can't see that. I'm doing a %.2 because that's what I saw in the picture was 2 decimal places. Let's just start with this and see what we get. The data that I pull as I range over the row. So one thing I note is that I'm not using the I, so I will ignore that part. So yeah, I know. You're going to see little warnings from my extra plugins. We can ignore those. Let's see what this does. I make 2 rows. I pass each of them to my display row, and then my display row should take each of them in turn and print them all out. They should be all zeros, but let's find out. Okay, there they are. So I notice the problem is that they're not side by side by side. And the reason why they're not side by side by side, like in the picture, but they're up and down, is because I'm putting a new line character after each one. So what if I take the new line character out? Okay, now they're all mushed together. So that's not desirable for one reason. There's no break between one row and the other row. So what I should do is print all the cells in the row, and then at the end of that, I will put a new line character. So I will print all the data side by side by side from the row, and then after I'm done doing that, I will print a new line character. So now you can see they are one row. Now they're all mushied together, so I still need to do something about that. And there's a couple of ways we can do that. But I do have one row and then the other row. So to demushify them, I could just put a space between them. So I'll print out the data followed by a space. But a cooler way to do this is actually to put a value in front of this dot right here. I'm going to say, I don't know, how much do I have? Let's say 10. So if you put a 10 in front of the dot, it kind of creates an invisible column of 10 spaces for that value. I'll show you what that looks like by running it real quick. So what's happening for each of these is that that's a little 10 space column. That's what the 10 did with 2 spaces after the dot, and then this one is in a 10 space column, and this one is in a 10 space column. So that's what the 10 does, is it puts them in these columns, and you'll notice that by default it aligns them to the right. So that's pretty sweet. For very little code, I can display as many rows as I could care to display. Now I'm going to go back and let's look at the use the picture as a reference. So I'm going to bring up my browser and look at this picture again. So in the picture I noticed that every one of the rows has a number in front of it. And every one of the rows has a bar and then some other piece of data after it. There's probably even more than that. Yeah, it's got some empty parentheses over there as well. So let's work on the number part. There's a number and then a colon and then stuff. and then a bar at the end. I might put the bar at the end just for fun. I don't know. I might. Okay. So what I'm trying to do is kind of mirror what they did. I'm only using 2 rows right now, but if I do it for 1 row. So I want to get that number on the front, and if I think about it, um, there's no, where would that number come from? Um, that this row 1 variable is actually row 1 for output. There's nothing in my code that actually provides that information. So sometimes uh, what you really need to be able to do is just say, well, I know that's row 1, and for that one I want a 1 to print out next to it. And I know this is row 2, and I want a 2 to print out next to it. Well, I'll just then add the number. When I call the function, I will just pass the number with the slice. So number and a slice. So now I'm going to go up to display row, and I'm going to fix the parameters so that it can handle that. So before I pass the slice, I want the row number, which is an integer. So to display a row, what I need is a row number, which will be an integer, followed by the row itself, which is a slice of float 64. And now I already know to anticipate this. I do not want to print 1, 1, 1, 1, 1 all the way across, so not in the loop, but before the loop, I'm going to print out the row number and a colon. I did not put a new line character here because I want the row number, and then on the same line I want the data cells, and then at the end of that line I want %n. For now I'm going to put the bar down here. Oh, yeah. You can't see the code, that's true. Okay. So what I've added, okay, so let me show you what I added. When I display a row, it occurred to me that I can't do what the picture's doing unless I actually just tack on the number. So I'm going to send the number along with the row. Send the number along with the row. Just checking to make sure you can now see. Okay, you can. And then in the function, I change the parameters so that the first thing that comes is the row number desired. The second thing is the slice of float 64. Then I print the row number and a colon, just like the picture. I do not put a new line character there because I want the data to follow on the same line. Then I use a loop to print the data. And then at the end of the row, I went ahead and stuck the bar in before the new line character. I'm not sure what that's going to look like yet, but I'm trying to just sort of do what the picture does. So the bar's a little bit mushed up, and I'm going to go fix that. But that's getting pretty close to what the picture does, so I'm pretty happy with that. I don't like the bar so close. What can I do about it? I'm just going to put for now I'm just going to leave it. That's fine. I'll worry about that later. You'll notice from the picture that there's something missing right now. So at present, the picture also has this other value and then something in parentheses. I don't have that part yet, so I'm going to come back to that after I give you another idea for another function. So displaying a row is not finished because there's actually, if we look at other pictures, there's 2 more pieces of data. So there's calculated data, and then there's a label to tell you what the calculated data means. So for example, in this picture, 44.42 is the calculated average of all the values on that row. So we're going to actually have to add 2 more parameters to our display row function, a calculated piece of data plus a label to tell us what the calculation was. But for now, I feel like we've got a decent start. So let's see, what else can we do for functions? Well, let's see what it means to edit a row. So I'm going to make a function called edit row, and then pass it row 1, and then I'm going to repeat. Now we're just sort of starting to put the pieces together here. But what I'm going to do is I'm going to display, and then I'm going to write a function to edit a row, and then I'm going to display them again because I want to see if my edits actually worked. So let's go set up an edit row function. So here's my display row, so I'm just going to go in the space below that. I'm going to write it so that it, in theory, should work for any row, not a specific row, any row. So I don't call it row 1 or row 2, I just say row, whatever, I don't care which row. I can edit, I should be able to, just like I'm displaying any row that I want, I should be able to edit any row that I want. Okay, so the trick here is they're editing like row 1, but you need to know which cell of row 1. So you're actually going to have to ask them a question here. You're going to have to ask them edit which cell. So you could number this for them 0 through 4, or 1 through 5 would be sort of the human numbering, if that makes sense. So imagine if like a friend or some older acquaintance who may not be programmer savvy, probably they're going to be more comfortable with thinking of the first cell as cell 1, even though we know in the slice that's actually index 0. But normally I'm going to ask them that. I can actually be fancier about this 5, by the way. I can put a placeholder in there and then have that be the length of the slice. So now I know it's going to be 5, but this is pretty cool because if the length of the row changes, then my prompt already knows what to do. Okay, so which cell? So now I'm going to scan the cell number. So that's the first thing you have to do is you got to get the cell number. Which cell? Then you got to get the data for the cell. I like to do this, by the way. You can kind of go crazy on this, but I can actually, well, let's fix a couple of things. I'm actually, what I'm doing is I'm trying to use the information that I can program in here to make these be more dynamic. So edit which cell, it'll say 1 through the length of the row, which is going to be 5, but if it were to change, that would dynamically change. Same thing here. So I'm going to prompt them for input, but as a part of that prompt, I'm going to tell them what the old value was. Before I do that, though, the cell number is going to be 1 too big because they're thinking I'm supposed to enter 1 through 5, but I actually know I need it to be 0 through 4, so I'm just going to decrement it to back it off by 1 right here. So they'll never see it, but now it's 0 through 4 again. Okay, so the prompt. I'm going to get that row, show them. So as a part of the prompt, I'm actually going to show them the current value at that cell number as a part of the prompt. So currently it's this is what I'll show them as I prompt them for new data, and then I will scan in the new value, and then I will store the new value. In the slice. If they mess up this number right now, the program won't like it. We'll worry about that later. If they type in a 10, that's going to mess things up. So we'll be careful not to do that. So, but what I'm pointing out to you here is that to do an edit on a row, um, once you get to this level, at some point you're going to have to ask them which row first. But you have to ask them the row, which we're not doing yet. Once you know which row, then you need to get the cell number of that row. Then you need to get the new value, and then you store that new value into that row at that index. So that's what all that's doing. For experimental purposes, what I'm doing is I'm displaying, yeah, if you're calling clear here, then it will do that. If you're calling it right there, then it will, yeah. I wasn't doing that, but yeah, if you put a clear where it says clear, it will definitely do that. Um, which is what the clear screen does, and it makes the display a lot prettier. Anyway, um, I didn't ask my user which row. That's something you're going to have to code. For now, I'm just going to edit row 1 to see if it works, and then I'm going to re-display row 1 and row 2 and see if the change that I make shows up. So there's it's just went straight into edit mode. Remember, there should be a menu here that says, I want to edit a row, and then your program says, which row? My one just says, which cell do you want? Because I want to quickly see if I can make this work. So I'll say cell 1, which I know should be cell 0. I'll just make it 1.23. And then the display shows, aha, there it is. Row 1 was edited. Cell 1, which is actually cell 0, gets the new value in it. So that worked. So that's 2 functions to work with. I'll put a note here. You got to know which row to edit by asking the user. I didn't do that part. But if your user says, I want to edit a row, you're going to have to ask them, which row do you mean? And then once you know that, you can say, okay, on row 1, which cell do you want to edit specifically? So it's 2 layers away, right? The row they have to tell you, and then the cell in that row they have to tell you. And then finally they have to input the data. I don't have a loop. Notice there's a reference to a loop here. I don't have a loop. I'm just giving you little bits and pieces that you can work with. Yeah. But what you want to do in this project is make functions that don't care which row it is. So that you're going to have 5 rows, so you want functions that are happy to take any of those 5 rows and work on them. And then I'm going to leave the code up, but I'll just sort of remind you that I have some screen captures to give you a sense of what my screen looks like in my running program. And I have it around somewhere, so if anyone wants to see a run, not the full code, but if you want me to fire up my completed project 3 and show you what it looks like when you run it, I can do that by request. No, you don't. The starter code is just there if people need the assistance, baby doll. So, um, no, there's no required format or approach. Yours, the last one I looked at of yours looked perfectly great. So, I wouldn't mess with your own way of going about it. This is just to help people who might feel like they're not sure where to take the first step. Okay, I'm going to sign off. I will be on at 10 a.m. tomorrow morning. Probably doing my COBOL programming, but if you guys have questions about labs or projects, it's usually just a couple people from your class, but feel free to drop by and ask me questions. Otherwise, I will be back for your class on Thursday at 2 p.m. So have a good day today, rest of today, and tomorrow if I don't interact with you before Thursday. Thank you too. See you later.